Okay, hello, Integrated Science. This is Mr. B, and we're continuing on with the sun. In our last video, we discussed nuclear fusion, how it is a stable energy source for the sun going on in its core. In this section, we're going to take a look more at the structure of the sun. So, what is the sun actually made up of? So, the first part is just the interior of the sun itself. There is the core, what's called the radiation zone, and the convection zone. So, those three make up the interior. That would be what you need to know. The interior of the sun is these three zones right here. Um, and before we get into that, we got to think, well, how do we actually know what the inside of the sun looks like? Again, there's no instruments we can obviously send there. Astronomers have to infer, which is kind of estimate and kind of use indirect evidence rather than just getting an actual clear picture of it to infer the structure of the sun's interior. Again, they use mathematical models. I'm thinking about monocles because I was hungry. Using mathematical models and the observations and that should say and the observations of vibrations of the sun that are similar to vibrations caused by earthquakes on Earth. So those again, there's different things going on within the sun, different movements of again, like I said, vibrations that would similarly be compared to earthquakes on Earth that can give us an idea of how things travel in the sun. So, how quickly some type of vibration can move through the sun will tell us maybe how dense something is, how big that area is. Again, we do similar things to the structure of Earth as well. Um, the sun's interior and atmosphere are divided into several layers with distinct characteristics. And again, we don't know those characteristics directly. We have to use indirect evidence by seeing how, observing how different things pass through the layers. So the first section we have is the core, and that is the central region where nuclear fusion occurs, which we talked about a lot in our last video. Um, it's a very large core with a diameter of 400,000 kilometers, which is a little more than a quarter of the diameter of the entire sun. So large core, lots of nuclear fusion going on in there. Again, 400,000 kilometers in diameter. Then the next area kind of moving outward, so core is the center. Right outside the core we have what's called the radiation zone. And you're able to see the sun because some of the energy produced in its core travels outward and escapes into space as visible light. So that, again, the core is kind of the driving force. It creates energy, energy escapes as visible light. Um, the radiation zone is a region of very highly compressed gas, and energy is transferred through the radiation zone by the absorption and re-radiation of electromagnetic waves. But because this region is so dense, it can take energy more than 100,000 years to pass through it. So it's a very thick, highly compressed area from, again, the outward pressure, kind of probably a mixture of the outward pressure from, again, nuclear fusion, the inward pull of gravity, makes this area very thick, so much that it can take 100,000 years for energy to pass through it. Then, again, core at the center, radiation zone. Next is our convection zone. So once energy passes through the radiation zone, it will enter the convection zone, which is the outer layer of the sun's interior. In the convection zone, energy is transferred outward mainly by convection currents. Remember, convection, hot air, or any hot fluid, if you will, can be air, gas, or liquid. Hot liquid rises, cooler sinks back down, and they make these currents, what are called convection currents. So the hot gases in the convection zone, again, they rise towards the sun atmosphere, while the cooler gases will sink back downward. So that is present on Earth as well, which I know, again, it's been a little while since we talked about those forces on Earth, but again, that is something that you should have hit on in the past. Again, hot gases rise in the convection zone, and then the cooler ones sink back down, creating these convection currents. And here's a picture. Again, this is a little bit kind of crazy right now because we haven't seen all these words. We have our core at the center right here. We'll just focus on these. Then we have our radiation zone, again, about 300,000 kilometers thick. And then we have our convection zone. These are our three layers of the uh, internal features of the sun. Again, core, radiation zone, convection zone. And so then after, kind of on the outside, we're going to see some of like the visible surface and what the atmosphere of the sun is made up of. So we're going to see more of these words here in a moment as we get going. Um, so the structure of the sun kind of outside the interior, the atmosphere, again, atmosphere kind of the outer layer, has three layers as well: the photosphere, the chromosphere, and the corona. The photosphere is like basically known as the surface of the sun. is the innermost layer of the sun's atmosphere. So again, we're still starting our way inward, working our way out. So we have core, radiation zone, convection zone, photosphere. So the photosphere is about 500 kilometers thick, average temperature of about 5,800 Kelvin. Again, this is what we know to be the sun's surface, and it has kind of a bubbly appearance, and the reason why it has those bubbles is from what are called granules, which are the tops of the convection currents, which come from the convection zone. So again, hot gas rising, cool gas sinking, and that will make itself apparent through the convection zone onto the photosphere. Again, photosphere being the sun's surface. That's probably the biggest thing you probably need to know for that. Again, then as we move out, we have what's called the chromosphere. So this is the middle layer of the sun's atmosphere, where again now our temperatures are up to 10,000 Kelvin. Again, at these temperatures, it's where like kind of a reddish gas is emits from, or sorry, a reddish light is emitted from hydrogen gas. Again, I can't remember early in the year. I think someone had a discussion on the color of the sun, and there was people saying they were orange, yellow, red. Again, that's kind of all of those colors. Again, the reddish part that we see comes from the chromosphere, and this faint chromosphere is actually normally visible only when the brighter photosphere is blocked, such as during a total solar eclipse. So we might not necessarily see all of this, but again, some of that reddish light might be kind of coming into factor of kind of who determines what the color of the sun is based off some of those pictures that people were looking up earlier in the year. And then our outermost layer is called the corona. Again, it's very hot. It's about 1 million Kelvin. Again, the most outer layer of the sun's atmosphere. Has a very low density, and then the total amount of thermal energy in it is relatively small. So again, it's not a very dense, there are not a lot of gases there, just the gases that are there are very high temperature, they're very spread out, they're moving very quickly at that temperature there. So again, not a ton of total energy there because there's just not a lot of actual particles existing in that area. Again, and it's so spread out, again, extends millions of kilometers above the chromosphere. So again, it's way out there. And because it's so far out there, it can gradually thin out even more and turn into what's called a solar wind. And that's a stream of electrically charged particles that flow outward from the sun throughout our solar system. So again, it's particles that come directly from the sun. Again, they're part of that corona. Again, when it thins out enough, it can be moved and travel to all different parts of the solar system. And then here's kind of a picture of the corona. So this is an eclipse. Again, a total solar eclipse. The only time you'll ever see the corona, again, is this outer edge kind of flaring around out here. These whitish, bluish particles looking out here. So this is these very hot gases that are moving, again, on the outer edge of the sun there. So again, now we're going to work our way backwards. Just review. Corona, outermost layer. Then we get the chromosphere, photosphere, and then from the, so again, we have this picture where I don't think the corona, then we have chromosphere, photosphere, convection zone, radiation zone, core, back to our center of the sun. So that's it for this video. Let me know if you have any questions.